This question is called basketball scores. It says a basketball player is taking 100 free throws. She scores 1 point if the ball passes through the hoop and 0 point if she misses. She has scored on her first throw and missed on her second. For each of the following throws, the probability of her scoring is a fraction of throws she has made so far. For example, if she has scored 23 points after the 40th throw, the probability that she will score on the 41st throw is 23 out of 40. After 100 throws, including the first and the second, what is the probability that she scored exactly 50 baskets? So, so the example I gave here, it says it was on the 41st throw, and she's made 23. On the 41st throw, the probability is number of points over total points. So, or total throws. And, oops. And obviously, every time you attempt a shot, your denominator will go up by 1. So, for let's say any possible sequence, your denominator will always be going up by 1. So if you ask yourself, what's the probability of, so we started off with a make and a miss, right? It says it right here. She scored 1 point and missed the second. Then the next, a basket has probability of going in of 1/2 because she made the first one and missed the second. So she has 1 make and she has 2 attempts. The next one, so let's say this one went in. The next one will have probability of scoring of 1/3. So if you want to say what's the probability of the next 2 going in, it's 1/2 times 1/3, assuming the first one went in, right? That means the denominator always went up by 1. So if you extrapolate this out for the entire remaining number of throws she has to like shoot, the denominator always goes up by 1. And we're saying the chances of her making this one and this one and this one and this one is, so you multiply, right? Because when you want to have some outcomes occurring, and you're saying we have to have them both occur, you have to use the AND operation, and the AND operation involves multiplication. So that means that whatever our overall probability is, it's going to be 99 factorial, because the first throw has probability of going in of 1/2. The next one, we're not sure if it'll go in or not, that the previous throw. It's going to be something, right? Either 2/3 or 1/3 over 3. Again, we're not sure over 4. We're not sure over 5. We're not sure over 6. So that's our denominator settled. As for our numerator, let's say she makes K shots. K scores and 98 minus K misses, because she has 98 remaining shots to go in, or attempts, because out of 100, she already shot 2. So now I have to figure out what the numerator would be. And so here, as you can see, in this situation, this is like our potential, like one possible sequence, right? 1/2 times question mark over 3, question mark over 4, question mark over 5, question mark over 6. So let's say, let's fill in a possible sequence. Let's say it was, so it was make, miss, right? Make, miss. And then let's say we have like make, right? Make, miss, make. So this one, the probability of this sequence so far, there's going to be more because there's 98 shots remaining, or 100 shots total. But we're trying to look at the first 6. Or the first 7. Here it was 1/2 of it going in. For this shot, there was 2 makes and out of 3 shots, so the probability was 2/3. Here, the probability of this happening is 3/4, right? For this one actually, but we missed, right? The probability of it going in was 3/4, but we missed, so probability of it missing was 1/4. So I'm going to write the misses in red. Then again, the next one here had a probability of missing of 2 out of 5. And this one, right, the next one was a make, had probability of making of 3 over 6. If you notice, the makes, so this is like make, and the reds were the misses. The numerators of the makes, if you just like reorder the multiplication, because you can, and like have all the makes side by side and all the misses side by side, so let's try that. So it was 1 over 2 times 2 over 3 times 3 over 6, and then it was times 1 over 4 times 2 over 5. We already addressed the denominators going up in increasing with the 99 factorial right here, but the makes also increase. If you notice, it's up by 1, up by 1, up by 1, and we're gonna have k makes, right? So when you multiply them out, if you have k makes and they're all, and you go like for all k, it's like the multiplication from 1 to k of n. It's just the factorial function. So we're gonna have k factorial go here, and as for the misses, same thing. They're also increasing every time. The value of the numerator is increasing. So here again, it's from 1 to 98 minus k n. This is like the multiplication function, or multiplication equivalent of summation. And so here it's 98 minus k factorial. Nice. So we have the probability of some exact sequence occurring. But let's say like k was equal to 5. That means we scored 5 times total in the remaining 98. Well, this could have been like make the first 5, miss the other 93. It could have been miss 93 to make 5, right? All we know is we made 5. And so we want to account for all possible ways to make 5. And there are 90, or k. So, and there are 98 choose k different ways to make k shots. So by doing this, we now have the probability of making some number of k shots in the remaining 98. So that's basically our answer. Now if we like simplify it, we're gonna get the actual solution. So 98 choose k, if we break down the choose function into what it actually represents, it's 98 factorial over k factorial times 98 minus k factorial. And we write down what we have here earlier, times k factorial times 98 minus k factorial over 99 factorial. And so if you notice, these cancel out, and we're left with 98 factorial over 99 factorial. And that's just like saying the same thing as saying 1 over 99, because all the other terms cancel out, right? 99, it's like 99 times 98 times 97, and over on top it's 98 times 97, So all these and all these cancel. So you're left with 1 over 99. And that's just telling us that the probability of making any particular number of shots that you choose is the same. So if you say the probability of making 1 more shot versus probability of making 10 more shots, or 15 or 25, they all have the same probability of 1 over 99. It's kind of surprising, but yeah, that's the answer. That's all.